Okay, so a revised version of a problem from the Forces in Motion review. We have Luke and Leia swinging from this cable across this chasm of the Death Star. This is not quite the way it happened in the movie, because in the movie the starting and ending platforms were at equal heights, whereas here there's a 1 meter difference. The cable is 5 meters long. Luke and Leia together have a mass of 120 kilograms. And so, what's the deal? This point here is 1 meter below where Luke and Leia start. So, right. So they go down 1 meter to the lowest point, and then back up to get to the final point, or the point where they get off. So, to start with, let's label our states. We're going to go with 1 as the beginning and 2 as the end for now. In order to make it to the left platform, what minimum initial speed do they have to have to leave the right platform? So, if you want to go through the whole, the whole work kinetic energy theorem, delta K, change of kinetic energy is net work, which then is the work done by gravity plus what other forces act on them. Well, we do a little FPD of Luke and Leia. We have, there's the cable, which exerts a tension force on them at some angle from vertical. I'm going to call that angle theta. Okay, and it could vary from here over to there, depending on where they're swinging, but it's always pointing the direction of the cable. And then mg, of course. So we know gravity does work on them, and whatever work the tension does. Tension is one of those things that always acts perpendicular to the direction of travel. So when they're here, the tension goes this way. When they're here, the tension goes this way. When they're here, the tension goes this way, etc. So this is going to be, in fact, I'm just going to, no, I'm not. Let's see. Let's try this. Okay, goodbye. So tension in the cable is going to be 0. Or sorry, no, not the tension. The work done by the tension is going to be 0 regardless. So this is really just then delta K equals work done by gravity. And since gravity is conservative, we can replace it with a negative change of potential energy, which of course means delta K plus change in gravitational potential energy equals 0. And then it's very easy to see that we just find initial and final potential energies, and we can find initial and final, or we can find a change in kinetic energy. So we know that at state 1, they have a kinetic energy of 1/2 mv1 squared, whatever that v is that they leave with. Okay, so they have an initial velocity here of v1. That's what they have to, or initial speed of v1. So that's their kinetic energy at 1. At their potential energy at 1, I'm just going to say, potential energy U is just gravitational potential energy here, okay? So initial potential energy is, of course, you have to define a 0 point for potential energy. So I'm going to say, since they start off, let's see, 4 meters below the anchor, well, what do I want to do? Let's see. Let me do U1 equals mg times h1. Okay, and then we'll worry later on about what h1 and h2 are. So at 2, they've gone to 0.2, which is at a different height, mgh2, and what minimum initial speed do they have here to make it over here? So what they need is, they need to have enough kinetic energy to make it here, or they need to have enough energy total to make it here. The minimum kinetic energy they can have when they get there is when they just barely make it there, and that is kinetic energy at 2 is 0. Okay, so setting these two equal, I mean, if the changes are, add up to 0, then the sum has to be equal. So what you get here is K1 plus U1 has to equal K2 plus U2, and 1/2 mv1 squared plus mgh1 has to equal, and then this is going to be 0 plus mgh2. And so what you get here is, let's see, 1/2 mv1 squared equals mg times, oh, that's interesting. The kitties are playing, and I think they're just slammed into a door. Okay, so mg h2 minus h1, we can cancel the m's. So cancel-y, and then you get their initial speed, v1 squared, has to equal 2 times g times h2 minus h1. So H2 minus H1 is just the change in height from the beginning of their swing to the end, and they go up 1 meter, right? So this is 1 meter. G on the Death Star is 10 meters per second squared because I said so. And this is 2. So this is going to equal 20 meters squared per second squared. And so, of course, V1 is the square root of that, which is, what is it, like 4.5-ish. Okay, so I'm not going to, whoops. So I'm just going to say here, V1 is whatever the square root of 20 is. I'm going to say it's about 4.5 meters per second. Honestly, I don't care. I'm not going to give you the exact answer. You can put a 20 in your calculator and hit the square root button just as well as anyone else. Okay, so great. They've done this. Now, what's the maximum tension the cable has?